Jumpa lagi dengan CR Aneka Teknik, channelnya tukang AC dan tukang listrik. Kali ini saya akan berbagi sharing pengalaman. Beberapa hari yang lalu saya mengikuti training tentang pengenalan gas Freon Refrigerant R32. R32 ini konon katanya akan digunakan pada produksi AC yang baru ke depan, yang mana refrigeran AC lama itu menggunakan refrigeran yang terakhir itu yang terbitkan 410 dan 410, R22, 407 dan sebagainya dan lain-lain banyak lagi. Nah itu nanti akan migrasi diganti dengan R32. Ini pada training ini sebenarnya pengenalan sifat dan karakter dari Freon ini, refrigeran ini, yang mana R32 ini mempunyai sifat yang berbeda dengan zat pendingin yang lain. Ini sifatnya flammable, mudah terbakar, makanya dilakukan pengenalan, training, SOP-nya seperti apa jika ada terjadi trouble atau kebocoran di suatu unit. Di unit ini, di pendingin ini memang harus dilakukan dalam SOP-nya itu perlu perlakuan khusus karena sifatnya yang mudah terbakar. Dalam training ini dijelaskan semua dari A sampai Z, dari sifat kimianya, terus sifat kimia macam-macam lah, segala sifat karakter plus minusnya semua dibahas di sini sampai dipraktekkan. Ini berapa besar volume R32 bisa terbakar. Ini dicoba juga sudah, ada videonya sudah semua, tinggal kita simak bersama-sama. R32 itu dalam training ini disebutkan, ini dalam bahasa Inggris, saya pun sedikit ngerti pun ada translator sedikit lah. R32 ini disebutkan itu friendly, jadi ramah lingkungan. Kenapa direkomendasikan untuk menggunakan R32? Ramah lingkungan, tidak merusak ozon, tidak menimbulkan tingkat pemanasan global paling kecil dibandingkan dengan refrigeran sejenis di kelasnya. Itu nanti bisa dilihat di tabelnya itu, nah, di sini. Nah itu ODP-nya itu paling kecil, jadi potensial pemanasan globalnya itu paling kecil dibandingkan dengan R410 dan R22. Sementara itu sajalah, untuk lebih jelasnya mari kita simak bersama-sama training ini. Mudah-mudahan kita bisa mengambil pelajaran dari training ini. Selamat menyaksikan, jangan lupa like dan subscribe-nya, bunyikan loncengnya, ting. Terima kasih, selamat menonton. Lama dari seperti 410, R22, kenapa diganti dengan R32? Karena ini dari penemuan mungkin dari para ahli, dari riset dan sebagainya, sampai saat ini yang terbaik adalah R32 karena memiliki kadar karbon yang paling rendah, jadi tingkat pencemaran lingkungannya sangat rendah dan mempunyai kelebihan lain seperti daya dingin yang lebih baik, hemat listrik, ramah lingkungan yang pasti karena sekarang zamannya friendly, ramah lingkungan, terus tidak merusak ozon. Kan isunya zat pendingin Freon itu merusak ozon, ya memang betul. Seperti R22 itu memang akan diganti, sudah mulai hilang, sudah mulai punah, kalaupun ada sekarang itu mahal harganya karena akan dihilangkan. Itu R22 dan kemudian diganti dengan generasi berikutnya dari R32. Sebagai pembanding, ini yang terakhir itu kan R40 itu kemarin itu memang yang paling baik lah kadar pencemarannya itu R410, kemudian muncul R32, sehingga produsen AC sekarang kebanyakan seluruh negara itu merekomendasikan menggunakan pendingin R32. Kelebihan dan kekurangannya R32 itu dibahas semua dalam materi training ini. Ini saya simpulkan saja lah, jadi saya simpulkan saja dari training kali ini. Dengan segala kelebihan dan kekurangannya dari R32, memang kelebihannya itu tadi saya sebutkan, ramah lingkungan pasti, kadar karbonnya rendah, terus tingkat pendinginnya lebih baik dari dibandingkan dengan zat pendingin yang lain. Tapi R32 itu flammable, mudah terbakar. Jadi ya itulah sisi kurangnya, itu mudah terbakarnya saja. Jadi kalau ada kita beli AC terus ada stikernya itu gambar api, ada tulisannya flammable, mudah terbakarlah itu. Salah satu itu dari R32. Sebenarnya ya kalau kita mengikuti SOP yang betul itu nggak usah takut. Yang penting ikuti prosedur. Jika ada kebocoran atau terutama kalau ada kebocoran lah, hindarkan sumber api, jauhkan dari sumber api minimal 2 meter. Kemudian jika ada kebocoran akan melakukan pengelasan, kita harus memvakum, membersihkan betul-betul dalam sistem, tidak ada freon yang tertinggal kalau akan melakukan pengelasan. Sebab apa? Namanya flammable, mudah terbakar. Kalau ada yang terjebak di dalam pipa, kita lakukan pengelasan, mungkin ada pressure sedikit, las panas lagi, itu memang potensial terjadi ledakan. Jadi kita mesti, makanya diadakan training para teknisi agar tahu SOP-nya seperti apa. Nah, dari trainernya dijelaskan semua, panjang lebar sampai prakteknya pun dipraktekkan juga. Berapa besar volumenya jika terjadi kebakaran R32. Semua ada dalam video ini. Mari kita simak, saksikan bersama-sama. Meskipun ini trainernya menggunakan bahasa Inggris, tapi zaman sekarang saya pun nggak pandai bahasa Inggris, tapi sedikit-sedikit paham lah. Oke kawan-kawan, mari kita saksikan bersama. Jangan lupa like, subscribe, bunyikan loncengnya. Terima kasih, selamat menonton.
Today's topic is R32 installation. So what we know about R32? Any idea that what is R32? Everyone? So in today's topic, we're going to see why we change to R32. Right? We are using R410 now. Right? When we say why we are changing to R32. Right? Life is very easy now. Use 410 very good. Why we have to change to R32? We're going to understand that a reason. What is R32? We're going to see. What are the standards? Standards means globally we want to recognize that okay, R32, these are the parameters that are internationally understandable to everyone, because every country has different regulations. So we want to standardize the international standards, European standards and American standards. So we will see what are the standards for all these countries or continents. Working with R32. This is the major thing why we are here, because we want to learn how to work with R32. So we can explain how to work with R32.
Okay, working with R32. So
focus how to work with R32, the surrounding, what is the requirement, what are the parameters to follow when we use R32 in our application. Okay, we're going to look into that. After that, service tool. What is service tool? What kind of service tool you use? Right. So we have different tools. So we're going to understand how it's different from R22, R410 and R32. What are the tools, how it's different, and where we can use common tools and where we cannot use common tools. Okay. Then safety. Very important, right? You are all wearing coverall. Safety, right? So we are going to look what are the safety standards and parameters to follow when you deal with R32. And then last, storage and transportation. Why storage and transportation is important? You all carry refrigerant in your van? Yeah. So when you carry, there is a chance it can catch fire. Right? So we should know what are the conditions when we keep this refrigerant in our van. So we are going to understand that. Right? And also when we are taking it from one side to other side, up and down, how do we carry that? Okay? So before we start, I'll show a video in English, but you will understand that. Huh?
Iya benar. Oh iya tekoi. Iya iya. Tidak rekod loh.
Precious as it is delicate. It's our responsibility to help take care of it. At Toshiba, our air conditioners employ a range of advanced technologies to improve efficiency and minimize their environmental footprint. Much like blood in the human body, air conditioners circulate refrigerants to cool and heat air. Recently, some of these gases have been linked to environmental issues such as ozone depletion and climate change. Choosing the right refrigerant requires taking into account all related issues and a holistic approach. Of course, it needs to be safe, but it also needs to be economical, efficient, and environmentally responsible. Until now, the consensus was that there needed to be a trade-off. At Toshiba, we believe R32 is the answer. R32 is a next-generation refrigerant that does not harm the ozone layer and offers a global warming potential that is about 3 times less than that of the current refrigerant, R410A. R32 systems are also much more efficient as they require less refrigerant than R410A systems. And because R32 is not mixed with other refrigerants, it can be recycled. Using R32, we offer a better refrigerant combined with Toshiba's renowned high level of performance and efficiency. Our proprietary Toshiba twin rotary compressor and inverter provide optimum control for maximizing performance efficiency. With a rotor in each compression chamber, Toshiba twin rotary compressor systems are compact, lightweight and low vibration, while requiring less space for installation. Rotors are offset by 180 degrees, an optimum control to maintain efficiency and save energy, whether operating at full power or low speed. Lineup: Daisekai.
So if CO2 is given by R410, how bad is it? Very bad. How much times? 1 time, 2 times? 3 times. Guess? Guess? No, not even 3.
More.
1,000? 1,000?
More.
More. 2,000?
Maybe more.
It's 2,080 times bad than carbon. So if you emit 1 carbon dioxide, you are emitting 2,080 times carbon if you are using R410. So in this cylinder, how many kg this one? Huh? How many kg? Kg.
Berapa kilogram?
13.
13.
Isinya.
How much? How many kilo? 13. Right? So if 13 kilo R410 go to atmosphere, 1 cylinder, how much carbon dioxide will go in the atmosphere? 22,080 cylinders. If you throw this cylinder, 1 cylinder of refrigerant in atmosphere, it's almost like 2,080 cylinders of carbon dioxide. Bad, right?
Translate.
Kita membuang satu silinder R410A ni ke udara kita ni, ia bersamaan dengan 2080 carbon dioxide, which is very bad for our global.
So in 1 month, how many cylinder you carry? In 1 month to site? Huh?
More than 10.
10?
Yeah, this.
So 20,000 cylinder of carbon dioxide you throw in the air. But carbon dioxide can be used by plants to cook food, photosynthesis. But this refrigerant, it goes in the air and it stays in the air. Right? So 20,000 cylinders per month you throw in the air and it's floating. Now you feel the heat, the temperature very hot.
Yeah.
Because we are responsible. We say, oh, car pollution, everything. We pollute 2,000 times more than car. Okay, so we try to understand how we can save this. So if you see, this is the history of refrigerant. From 1834, they were using ammonia, water, sulfur, all natural type of gas for cooling and everything. Right? Then we came here. You see this time, 1926. You read here, what is the name here? Willis Carrier. Dr. Willis Carrier. Right? In 1926, he made a machine, centrifugal chiller, and he also made a compressor that runs on man-made refrigerant. So almost 100 years ago, for the first time we start using methylene chloride, a refrigerant that was man-made, synthetically produced from in our nature. Right? Then from 1931 to 1990, we use all chlorine, fluorine, all man-made refrigerants. And at this point here, we realize, oh, ozone problem.
Okay, refrigerant ni
Any man-made refrigerant.
refrigerant ni refrigerant bahan penyejukan yang orang buat, yang sebenarnya yang dibuat oleh manusia. Bahan penyejukan yang dibuat oleh manusia, bukan yang semula jadi.
Understand? Huh? So when we choose this man-made refrigerant, what are the criteria to choose? Operating pressure. You go to site, what you do? If someone complains they are not cooling, you need to use skill level of design engineers and technicians who install service and maintenance. So this is easy to use, easy to install, easy to repair. Good for all technicians, right? We want everything easy. Open the screw, fix it, nice. No need to brace, no need to weld. Easy, right? So we want everything to be easy. So if you see, this is the alternate refrigerant. HCFCs, these are all with chlorine. Then HFCs, no chlorine but have fluorine in that. And halogen free. What is halogen free? Anything that is chlorine or fluorine not there is halogen free. Halogen is a group in our element chart. These are types of refrigerant. Tricky, try to understand, we can forget also, no problem. What is halocarbon? Synthetically produced, that is man-made. Man-made Freon family of refrigerant. We all know what is this? You call Freon, right? Huh? So any refrigerant man-made is Freon. They change. Okay. So R410 is azeotropic or zeotropic? Huh? R410
Geotropic.
Is zeotropic or azotropic?
Geotropic.
What do you mean by zeo? What do you mean by zeo?
Zeotropic ni yang macam dua liquid lah, A, B. Dia bersatu. Tapi kalau sudah ia bertukar ke komposisi lain menjadi gas, ia akan memecah. Kalau azeotropic, kalau A sama B ni bercampur, kalau ia jadi gas dia masih bersama. Atau azeotropic. Kalau azeotropic dia berpecah kalau jadi gas.
So for
Percaya.
R410, this one has two refrigerant. So you don't have to turn or do anything here. This one, liquid or gas, any line is the same.
Pure.
Kalau habis kita menggunakan R32 ni, sorry ya. Terus kalau menggunakan ni, habis kita akan charge, you dah tidak boleh dikembalikan. Okay? Lain dengan ni. Kalau yang R410, kita mesti kembalikan ni.
Okay?
Okay.
And then there is inorganic refrigerant. Any refrigerant that has carbon is inorganic. So these are the future refrigerants. Next 5 years, we will be using these refrigerants. Do we use this ethane, propane, isobutane as refrigerant? Do you use this? As well as HCFCs and HFCs are often very effective greenhouse effect. What do you mean by greenhouse effect? Huh? This is plastic shed. We use for car shed, right? In our house shed. Afternoon, this one very hot, right?
Yeah.
Why is it very hot? Radiation comes in, but trapped here, cannot go out. So trapping of this refrigerant or heat is called as greenhouse effect. So what this refrigerant do, when this is your earth, this is your atmosphere, here you have all the refrigerant. Sun radiation comes, hit the earth, go back. It is trapped at this refrigerant point and it will heat the earth atmosphere, and that is called global warming potential due to greenhouse effect.
Bayangkan dari bumi kita ni. Bumi kita ni, di luar bumi kita ni ada udara. This is ozone layer.
The ozone layer would be upper surface.
So this is supposed to be okay. Di luar ni
Yeah.
udara kita ni.
You see, this is ozone layer. This is refrigerant, ozone layer. This is earth atmosphere. So for
Okay.
Ada.
Bumi sini kita yang punya udara. Bayangkan radiasi daripada matahari itu masuk ke kawasan bumi kita ni. And then dia masuk tapi ia keluar daripada udara. Masih di dalam udara. Setiap hari udara itu panas. Seperti yang kita lihat sama-sama.
Ada UV, UV tidak boleh keluar sebab dia refrigerant sana. So UV kalau masuk tidak boleh keluar lagi, bounce back.
Yes.
Udara sana
something like this. So this is your earth. This is your refrigerant. Sunshine coming to earth gets reflected, but due to this refrigerant here, it cannot go out.
Global warming potential. Pemanasan global.
Okay. Then there is ozone depletion potential. So
Ozone depletion.
what is ozone? There is no ozone anymore because this chlorine came and took the oxygen. So no more layer. Sun radiation will directly come, hit the earth. And what will happen? If radiation very high, we go for X-ray, right? X-ray says, oh, only particular parts. So those radiations can pass through your skin layers. And with ethane, propane, so these are all types of HFCs that does not have chlorine. So this is our earth. Looks colorful? Huh? It should not be colorful. It should have been green. This green or yellow all across. But due to our global warming and ozone, you see this layer depleted, all greenery gone and become to this level of blue. Refrigerant. Why we need new refrigerant? To protect our ozone and to protect our earth. So if you see here, 100 years ago, we were using natural refrigerant, carbon dioxide, ammonia and hydrocarbons. After that we came into CFCs. What is CFC? Chlorofluorocarbon. And then we have this Montreal Protocol ozone depletion. At this time in 1990s, all the government from all across countries came and found out that, oh, we have to save the earth or else in next 20 years. What happened? Because it is above upper flame limit, because strong, very strong, right? So if we reduce little flame, you see what happens. We don't have proper lighter. You see? You see this flame going up? But it's strong. Not nothing, it won't happen. You see? Slow LFL limit is there, right? But it's not catching fire, it's just burning only. Because the speed is less than 10 centimeter. If more than 10 centimeter, it will catch fire for long. Okay, see, this burning is toxic. You want to smell it? Come. Open. Ah. just fine, nothing there. So nothing to worry about. So once we connect everything, first we come and see, okay, on the unit, 10 minutes. 10 minutes we run the CDU because CDU is off, right? So 10 minutes we run. Proper cooling there or not there? You see, okay, what's the temperature? You measure the temperature gun. If 11 degree, 12 degree, you measure the return temperature how much? 6 degrees, okay already. Okay. Right. Then if you want to cross check one more time, see what the pressure is. Right? 5 minutes you run the unit, you see the pressure. If 150, 160, okay. But after 20 minutes, check one more time. Pressure going down or going up. If pressure going down,
Going up lah.
leaking.
Oh, leaking ah.
See? So our job is connection, check leak, run away, go home. No. We have to wait for 20 minutes to check all cooling, everything, all parameters are okay or not after commissioning.